This video is going to cover hypothesis testing for the difference between two independent means. Here I have the steps for hypothesis testing with two independent means. The first thing you need to do is make sure you state your null and alternative hypotheses, and these are the different options. Notice that they are comparing mean 1 and mean 2. Then you need to determine which of the two tests you need to use. There are two tests, the 2-SampZTest and the 2-SampTTest. Okay. This flowchart will help you to determine which one you need to use. Once you determine the correct test, then you will get the p-value from the test. Okay. Then you can compare your p-value to your alpha, and that'll determine if you reject or fail to reject HO. Then you'll use the following chart to determine how you state your final conclusion. So let's look at an example here. A vet claims that there is no difference in the mean number of fleas of cats and dogs. The results from a random survey are shown below. The two samples are independent. Do the results support the vet's claim? So the first thing I need to do is write my null and alternative hypotheses. So he's saying that there's no difference between the mean number of fleas of cats and dogs. So he's saying that the mean of cats is equal to the population mean of dogs. Because this has an equal to symbol in it, that means it needs to be a null hypothesis. Okay, so if you look at up here, the null and alternative hypotheses are always the exact opposite of each other. The null hypothesis always has some kind of equal sign in it. And if the null hypothesis is equal to, the alternative hypothesis is not equal to. So let me write claim here. So that means my alternative hypothesis is mu1 is not equal to mu2. Okay? So now I need to figure out, am I going to use the z-test or the t-test? Okay, so the first thing I need to look at is, are they both normal or approximately normal? Well, it doesn't say anything about that, so I'm going to go to no. Are both of the samples greater than 30? Well, you can see sample 1 is 50 and sample 2, these should be little 2's, sorry, 2. And sample 2 is 35. So yes, that means we're going to use the 2-SampZTest. Now, the test is going to ask us for sigma 1 and sigma 2, but we do not know those, so we're going to be able to use S1 and S2 in that place because n is greater than 30. So let's go to stat, then we go over to test, and notice right here is 2-SampZTest. So number 3, it's going to ask for data or stats. Data would be if you were given two charts with all of the data, like if you were to have the amount of fleas for each one of those 50 cats, if you had that chart, instead of actually having the data given to you. Instead of actually having the statistics given to you. Since I have the statistics, I'm going to select statistics. Okay, sigma 1, like I said, we don't know sigma 1, but because n is because n is greater than 30, sigma 1 is approximately equal to sigma 2, or sigma 1 is approximately equal to S1, and sigma 2 is approximately equal to S2. So I'm going to put 15, 28, x bar 1 is 208, n1 is 50, x bar 2 is 218, n2 is 35. Okay, when you get to this point here, you want to make sure that you highlight whatever the alternative hypothesis is. The alternative hypothesis has the symbol of not equal to, so I need to make sure not equal to is highlighted. So I highlight it, press enter. Then I press down, highlight calculate, and press enter. So P, where's my mouse? P is equal to 0.0538. Now what I want to do is take that p-value that I found here, 0.0538, and I want to compare it to my alpha. In this case, alpha was 0.05, so P is greater than alpha. So that means I fail to reject HO. Whenever P is greater than alpha, you fail to reject. If P is less than alpha, you reject. The way I always remember it is if it's greater than, it's the one with more words. Okay, so notice the less than symbol has less words, the greater than symbol has more words. Okay, now I need to figure out how I'm going to word my conclusion, and it's going to be based on this chart here. Is the claim HO? Yes, it was. Did we reject HO? No, we didn't. So we say there is not enough evidence to reject the claim that. So there is not. That the mean number of fleas between cats and dogs is the same. Or you can say there is no difference, whatever is the same. Okay. The braking distance of 8 Japanese cars and 10 American cars were tested when traveling, let me fix these, at 60 miles per hour on drive pavement. The results are shown below. Can you conclude that there is a difference in the mean braking distance of the two types of cars? Use alpha at 0.01 or 1% level of significance. Assume the populations are normally distributed and the population variances are not equal. So the first thing I need to do is state my null and alternative hypotheses. So can you conclude that the difference in the mean braking distance of the two, there is a difference. So can we conclude that they are not equal? So the claim that we're trying to test is that the mean of the first one is not equal to the mean of the second one. This is my claim. Now because this has a not equal to symbol in it, this is HA. Now the opposite of that would be HO, which will use the equal to symbol. Okay, now I need to figure out which test I need to use. Okay, so the first question, are they both normal or approximately normal? Now it does say assume they're normal, and it also says the population variances are not equal, which will be one of the future questions. So are they normal? Yes. Are both sigma 1 and sigma 2 known? Okay, so if we look at this, it doesn't in any place tell us sigma 1 and sigma 2, and we don't have it here either. The only time you can assume that sigma 1 is equal to S1 is when n is greater than or equal to 30, so we don't know sigma 1 and sigma 2. So no. Are they equal? It said to assume that they are not. Assume that they are not equal, because this is the variances. Are the variances equal? No. So we use the 2-SampTTest, and we need to make sure that we highlight no next to this pooled. Okay, so pooled is essentially just asking if where it says are they pooled, that means if you say yes to pooled, that means the variances are equal. If you say no to pooled, that means the variances are not equal. Okay, so with this one I use the 2-SampZTest. With this one, I'm going to use the 2-SampTTest. Okay, so we'll go to stat, over to test. 2-SampTTest is t-test number 4. Make sure stats is highlighted. X bar 1 is 134. S1 is 6.9. N1 is 8. X bar 2 is 143. S2 is 2.6, and N2 is 10. Okay, now it's going to ask us to highlight the alternative hypothesis, which is already highlighted from the last example. It was the same thing. And here it's saying, is it pooled? So are the variances equal? No. Make sure no is highlighted. Then highlight calculate. P is equal to 0.00727. So in this case, P is less than alpha, so that means we reject HO. Okay, but our claim was not HO, our claim was HA, so let's use our little chart up here. Is the claim HO? No. Do you reject HO? Yes. So we say there is enough evidence to support the claim. And see that there is a difference in the breaking type. There is a difference in breaking distance for the two types of cars. Okay. A news reporter claims that there is a difference in the mean credit card debt of women and men in the United States. The results of the random survey of 200 individuals from each group are shown below. The two samples are independent. Do the results support the organization's claim? Okay. So the first thing I need to do is figure out what the claim is. That there is a difference, okay, so that just means, that's like number 2 that we did, that mu1 is not equal to mu2, and that's the claim. So that's my HA, therefore my HO is mu1 is equal to mu2. Okay, now I need to figure out, am I going to be using Z-test or a t-test? So are they normal or approximately normal? It didn't say anything about that. Are both greater than 30? Yes, because they're both 200. So I use 2-SampZTest. In general, most people just go ahead and use Z-test if they're both greater than 30. Okay, so I need to use 2-SampZTest. Alright, so stat test number 3. Okay, we don't know sigma, but we can approximate sigma 1 with S1, and we can approximate sigma 2 with S2. I didn't change all these variables here. Okay, so sigma 1 is approximately 750. Sigma 2 is approximately 800. X bar 1 is 2290. N1 is 200. X bar 2 is 237. Oops. N2 is 200. And it's kind of annoying that the two ask these variables, the Z-test and the T-test, ask them in different order, but they do. It's annoying, but you get used to it. Calculate. Okay, so the value that we're looking for is the P. So here it is. P is equal to 0.302. Okay, so alpha is 0.05. This is definitely greater than this, so P is greater than alpha, so we fail to reject. HO. So now let's figure out how we're going to word this. Is the claim HO? Was it? I don't think it was. I think it was HA, right? Yeah, sorry. Is the claim HO? No. Do you reject HO? No. there is not enough evidence to support the claim that. Okay. There. And we were talking about credit card debt, right? That there is a difference in credit card debt among men and women. Okay. A router manufacturer claims that the range and feet of its newest router is greater than that of its leading competitor. You perform a study using 14 randomly selected routers from the manufacturer and 16 randomly selected similar routers from its competitor. The results are shown below. At alpha equals 0.05, can you support the manufacturer's claim? Assume the populations are normally distributed and the population variances are equal. So the first thing I need to do is write out my hypotheses. So it says that the range is greater than the competitor, so the mean range of the first one is greater than the mean range of the second one, and this is the claim. Now, because this has a greater than symbol and it doesn't have any kind of equality in there, that makes this HA. Now HO is going to be the exact opposite of it, so we'd have mu1 and mu2. Now, since this inequality symbol is pointing to the right, this one will point to the left and contain an equal sign on the bottom. Now I need to figure out if I'm going to use the 2-SampZTest or the 2-SampTTest. So I'm going to use this chart up here. Are they both normal? It did say they were. Are sigma 1 and sigma 2 known? We did not know them. So no. Are the variances equal? It said yes. So we're going to use the 2-SampTTest, and we want to make sure we highlight yes under pooled. Yes means that the variances are equal. Okay. So we go to stat. Let me write that here. 2-SampTTest. Okay. So we go to the 2-SampTTest, which is number 4. Make sure stats is highlighted. Okay, 1275. Oops. Enter. 45. Whoa. Okay. 14. 1250. What is it? I keep hitting that 1 twice for some reason. 1250. 30. And 16. Okay, we want to make sure we highlight whatever the alternative hypothesis is. In this example, it's greater than, so I need to highlight the greater than symbol. Pooled is yes, because the variances are equal. So I'm going to make sure I say yes. Then calculate. So the value I'm looking for is that P right there. So P is equal to 0.0404. In this example, we're looking at alpha being 0.05, so P is less than alpha, so we reject HO. Okay, so if you go up to the top, HA was our claim, we rejected HO. Is our claim HO? No. Do you reject HO? Yes. So there is enough evidence to support the claim. And that's it. The big thing that I recommend doing is having, especially these two charts here, this one tells you which test to use, this one tells you how to word your final answer. This is the same thing that you would use for every type of hypothesis testing. This one right here is only used for two independent means. And this is also always the same for all hypothesis testing. If you get p less than alpha, it's always reject HO. P greater than alpha, it's always fail to reject HO. Like I said, the one with the greater than symbol has the more words, the one with the less than symbol has less words. That's the easiest way to remember it.